Hello, and welcome to this video on deploying the OHDSI-in-a-Box solution. This video will walk you through how to deploy OHDSI-in-a-Box, which is a single VM personal learning and training environment for the OHDSI toolset and the OMOP Common Data Model. And it will walk you through how to deploy this solution on the Amazon Web Services Cloud. So step one is really to find the OHDSI-in-a-Box GitHub repository. That's where you'll find the documentation and links to start deployment. And you can do that by just Google searching OHDSI-in-a-Box. And it's the first link that comes up. This is the OHDSI GitHub organization and the OHDSI-in-a-Box repository. And so you can see here the files that are included as a part of the project. So this is really the automation code and documentation files. In order to use this solution, you really don't actually have to interact with these files very much, but what you're really looking for is the documentation here. And so you can see it gives just to kind of overview the documentation, it gives a brief description of the solution, a single VM where you can learn about OHDSI and OMOP. And it also talks about the fact that there are, in fact, two versions of OHDSI-in-a-Box, one based on Linux and the other based on Windows. And the main difference is that the Linux version obviously it runs on the Linux operating system, and it costs about 40% less in terms of the compute charges due to the way that Linux and Windows VMs are priced in the AWS cloud, and based on the cost of the Microsoft Windows operating system licensing, it results in the Linux version being about 40% less expensive. And so you can see here for each version there are links to deploy that VM inside of certain geographic regions within the AWS cloud. So this can currently be deployed in China, in Europe, particularly Ireland, in the APJ in Japan and Tokyo, and then also in the United States and Northern Virginia. And that's also true for the Windows version. And it also gives you a table of the majority of the OHDSI projects included in their version number. So when you deploy this, all of these OHDSI projects are pre-configured and installed in this VM. It shows you what versions are available, as well as the sample data sources that are available and are already configured inside of the OHDSI tools, inside of Atlas, and they're already in the database in the OMOP Common Data Model, so that you have some data to try these tools out and learn about them. And then the passwords associated with how do you connect to this VM once it's deployed using the remote desktop protocol. What username do you use? And then once you're connected, how do you connect to the Postgres database running on the VM? What username do you use? What password do you use? And then again, the same for the Windows version as well. Largely the same geographic regions, mostly the same OHDSI project version numbers, and so and mostly the same data sets as well. The rest of the documentation gives you an overview of how the solution actually works. So again, it is a single VM with many of these OHDSI projects installed, and you connect to it via remote desktop protocol. We'll go over how to do that. And then there's some detailed instructions here on what to actually do, the parameters that you configure, and some documentation on how that works. So we'll get right into it. We'll assume that I'm going to use the Linux version, and I'm going to deploy it inside of the United States in Northern Virginia. So what I do is I've already signed into my AWS account. So I'll just click on the Launch Stack button. And you can see it's taken me into my AWS account console. If I hadn't signed in already, it would prompt me at this point to sign into my AWS account to provide my account number, my username, and my password. But in this case, I've already signed in. So this is the AWS service called CloudFormation. It's an infrastructure as code service that allows you to automatically deploy infrastructure inside of AWS, and it's what we built the OHDSI-in-a-Box solution on. So at this screen, basically I just hit next. It's kind of pre-populated this template, which is what tells AWS how to deploy OHDSI-in-a-Box. So I'll click next. The next are the parameters that I'll provide. So I can name my stack. By default, it's called OHDSI. I'll just call it OHDSI-in-a-Box test. And I can provide a password to connect to the instance. So this is what I'll actually use to connect to the instance via remote desktop. You can see it has some complexity requirements, has to be of a particular length, it has to can only use certain characters. So I'll type in my secret password. You can restrict IP address access to this by providing an IP mask. This is really optional. What is here by default would allow anyone on the public internet to be able to connect if they knew the password to the instance. If you know for certain, kind of the IP range that people will be connecting from, then you could add that here and sort of increase security. And also the number of OHDSI-in-a-Box instances to deploy. So it may seem kind of confusing at first, like why would you want to deploy more than one? But this is often used for training classes where you may have up to more than 100 people at one time that are using this. So being able to easily increase this number just prevents you from having to run this automation over and over and over again. I'll do 3 as an example just to show. The instance type, this really determines the CPU and memory configuration and the overall performance of the instance. So this is largely kind of a performance versus cost consideration. We have found that typically the T3 Medium offers probably the best balance between cost and performance. But obviously, if you wanted faster performance, or if the performance wasn't acceptable with the T3 Medium, you could increase that to a larger size. The configuration of these instance types is available in the AWS documentation. If you just Google EC2 instance types or AWS instance types, you can find what are the CPU and memory configuration of each one of these names, and what is the exact hourly rate and things like that. By default, you need to provide 100 gigabytes of disk space for the OHDSI-in-a-Box instance, but sometimes people want to be able to upload additional data or have room for additional data, so you can increase this to 120, 150, really any number up to 16 terabytes. Of course, increasing the disk space also marginally increases cost as well, so something to consider if you need additional space. And then the networking, AWS inside of your AWS account has something called a VPC, or a virtual private cloud. This is a private network address space inside of AWS. So this is just specifying where inside of your AWS account from a network perspective do you want to deploy these instances. So by default, accounts have what's called a default VPC, and it has this IP address range. You can see I actually have 2 here. I've created another one, but typically, if you're not already familiar with where you would want to deploy this, you would choose the default VPC, which is going to have this address range, 172.31.00/16. And then also you'll want to choose a subnet that is within that range as well. So basically that it starts with 172.31 and then 2 other numbers. You can see this subnet starts with a 10. It's actually a part of the other VPC. So I wouldn't want to use that because they wouldn't match, and this deployment would fail. But I can choose kind of any of these other subnets that start with the same 2 octets. So now I've provided all of my parameters, and I'll click Next. Here you have some configuration options where you can apply tags, add additional permissions. None of this is really necessary to use the base OHDSI-in-a-Box. So if you're not familiar or you don't already know what you want to do with these options, then you can effectively just ignore them. And then the last screen is a review screen where it kind of gives you an overview of what is about to occur, all the configuration parameters that you supplied. And then there's also this notification that as a part of this automation, AWS has recognized that, hey, this is going to create something called an IAM role, which is going to give that EC2 instance permissions to do certain things within the AWS cloud. And so what you want to do is just check the box and say that you acknowledge that it's creating this role, and create stack. And you can see the automation process has started. It says create in progress. And you can hit this little refresh button here to see the progress that it's going through. So it's creating and completing certain resources within AWS that are standing up this VM. You can see the overall stack over here is not completed yet. So we'll just refresh. This only takes a minute or so to deploy. All right, you can see now that my CloudFormation stack has completed, and I can go to the Outputs tab, and it will give me a link to view my OHDSI-in-a-Box instances. All right, and you can see here that I do in fact have 3 OHDSI-in-a-Box instances that were deployed. You can see they're denoted by this name, the name that's associated with the stack that the stack name that we provided. They are the right instance type that we specified, and you can see that even though the stack has completed, these VMs or these instances are still kind of booting up. But here are their IP addresses. So what we want to do is just wait a minute for them to kind of boot up and initialize, and for the password to be set to what we specified, and then we'll be able to connect to the VM. So this process, the kind of the boot up process, usually takes just 2 or 3 minutes. It's a little longer on Windows, so I would probably wait 4 or 5 minutes on Windows before I tried to connect. But then we'll be able to connect to these VMs via RDP. So I'll take the one of the IP addresses. I'll just connect to the first one as an example. And this is my remote desktop client on the Mac that I'm on. There's also similar remote desktop client for Windows and also for Linux if you're using a Linux desktop. You can find links to those in the OHDSI-in-a-Box documentation in the GitHub repository. But I'll create a new connection, and I'll name this OHDSI-in-a-Box test. The PC name, I will paste the IP address here, and the username, as in the documentation, the username is always Odyssey, and the password is the password that I supplied. And I'll just change some of these other parameters that'll make it easier for us to see, not go into full screen mode and things like that. But that's pretty much the entire configuration. So now you can see down at the bottom I have my new connection. So I'll just double click on it to start the connection. And you can see it's asking me, it's saying, hey, you have never connected to this particular endpoint before. RDP, the remote desktop protocol connection, is encrypted, and basically it's asking, hey, do you want to trust this connection? And I'm going to say connect always, that I'm okay with connecting to this particular endpoint. All right, now you can see the OHDSI-in-a-Box Linux desktop. It's very plain. You have the shortcuts here to, kind of some basic Linux operating system, browse the file system. This is kind of like the Explorer in Windows. You have a terminal, which is a standard Linux command prompt, and then links to many of the Odyssey tools and documentation. So White Rabbit, Rabbit in a Hat, and Usagi, and also the Google Chrome link to the Atlas tool, and also RStudio, which has many of the Odyssey R libraries installed. So I'll start by just opening up Chrome, and we'll see the Atlas interface. And you can see in Atlas, this is the web interface where you can perform many informatics functions. And I think the thing I'll focus on showing is the availability of the three data sets that were mentioned in the documentation. So you have the Cynthia 1K or 1,000 person data set. And using this data sources link, you can see an overview of this population. So this was generated from the Cynthia project, which generates synthetic patient data. And you can kind of see an overview of this population here that's captured within this data source. And of course, you can explore kind of other attributes or other characterizations of this population, such as the prevalence of conditions, or many other attributes of the population. Also, for the 2 SynPuff data sets that are available, these are synthetic claims data data sets that are made available from the Center for Medicare and Medicaid Services in the U.S. So this is synthetic public domain data that also kind of characterizes a population. So you've got 1,000-person population. Again, you can see, and again, it's based on Medicare claims data, so you can see the age skew here as well. And you also have 100,000-person population also of this synthetic data. Then here's where you can kind of start to use and learn many of the different functions of Atlas, such as defining a cohort. You can use all of this through the web interface, so I'll minimize that. Then, of course, there is RStudio, which is included as well on the VM. So this is an R development environment that has many of the OHDSI packages pre-installed, so you can see cohort method and the database connector, patient level prediction. These are all libraries that are pre-installed, and you can just invoke them the way that you normally would invoke any kind of R library, and they load correctly. So you can start to develop packages for this in the Atlas web interface, and then open them inside of RStudio and execute them and run them against the data that's stored in the OMOP Common Data Model in the Postgres database that's local to this VM. So speaking of that, we'll kind of explore the way that you can connect to the Postgres database local to this virtual machine is through SQL Workbench. So you can see it is pre-configured, this connection. It already is populated with your OHDSI username, the URL to the local database, the password that you specified as a parameter. It's all sort of pre-populated here, so you just need to click OK. And it's connected to the database, and you can use the Database Explorer tool. So tools, show Database Explorer to see the various schemas that are available here. You can see again they match the data sources that were mentioned that you could see in Atlas. So there are two schemas for each data source. One, the one without the word results. So Cynthia here, Cynthia 1K Postgres. This contains the patient level data in the OMOP Common Data Model as well as the vocabulary tables, and then the Postgres results contains the characterization information generated by Achilles that kind of describes metadata about that population. So, and here I can start to, I've gone into the sort of the main schema, and you can see all of the different tables that make up the OMOP Common Data Model, and then of course you can start to explore, through this tool. If you wanted to actually see the data itself that's in these tables, you can start to see this data, and this can be a good way also to kind of explore and understand the data that's actually how data is stored in OMOP, and why you're seeing the results that you're seeing or things like that. So those tools. Then of course you have the White Rabbit, Rabbit and Hat and Usagi tools. You can open these as well. These are Java-based tools that primarily help with mapping and ETL for source data to OMOP. So you can explore using those. You may want to use those with data that you are uploading to this excuse me, to this VM directly, and like your own sample data that you may want to practice mapping to OMOP. Then there's this text file here, connection details.txt. This just shows the username and password that you specified, the different database schemas in an R format, and so you can use these and copy these in order to enable connection from your R program to the local database that already has sort of a connection string and everything established for you. So once I'm all finished doing what I want to do with these instances, I'll just close my remote desktop connection. If I wanted to, kind of temporarily suspend what I was doing, like maybe I wanted to come back to it later, I could right-click on one or more of these instances and tell the instance to stop. which is kind of, you can think about it as kind of being turning off the computer, so to speak. So it stops the charges for the compute portion. You still pay the smaller portion of the fee, which is for the active storage, so the 100 or 150 gigabytes of storage, but it does prevent the running compute charge for the instances that you deployed. So this is a good way to kind of pause if you wanted to come back and work on it later. Another way to do this would be if you wanted to stop the kind of active storage charges as well. You could create an image of this machine, and then that would actually allow you to terminate it, and you would just pay for the kind of inactive image storage, which is even less expensive, and then you could boot that machine back up again later and continue working. So those are both options to kind of pause working. But eventually, you'll want to shut these machines down and stop all of the charges permanently. And so the way that you'll do that is just by going to the Services tab and typing in CloudFormation. And this will take you back to this kind of familiar interface, the one where we actually deployed the OHDSI-in-a-Box instances to begin with. And I can just select this stack, the OHDSI-in-a-Box test stack. If you had deployed more than one of these, you may have multiple stacks. But this stack basically encompasses all of the instances that we deployed. So if we had chosen just one instance, this would represent just the one OHDSI-in-a-Box instance. We deployed 3, so all 3 of them are kind of captured in this stack, and I can just say delete stack. And now the delete will begin. And this will take really just a minute or so to complete. Okay, and you can see now that the delete is complete, and the stack is completely gone. So now all of those instances are terminated. We don't have any more charges for the computer, the storage related to them. So yeah, this kind of completes the OHDSI-in-a-Box lifecycle. Thanks for joining and for learning about this solution.